Kids have been hearing it for thousands of years now. Before they come inside, before they eat, they're told to wash up, clean off the dirt, and not just with water, with soap and water. Why wash? Well, dirt and filth on food, clothes, or skin contribute to illness, disease, infection. Why wash with soap? Because water alone is pretty superficial. If you could observe water at the molecular level, here's what you'd see. Huge masses of tiny H2O molecules sticking close together, a kind of hyperactive, hyper-exclusive click, held closely together by their mutual and continuous attraction to each other. One happy, clickish party, except for the H2O molecules on the surface. They're surrounded by their click at the sides and below, but not above. Those parts are exposed to the air. No mutual attraction there. So an H2O molecule at the surface shrinks away from the air, pulls even closer, tighter to the H2O molecules next to and below it. This outward and downward pulling stretches the exposed top part, forming a thin membrane, like an invisible skin.
If the molecules have strong intermolecular interactions, if they're very sticky to one another, then it's very hard to pull them apart, and we say that that has a high surface tension.
Surface tension explains why a metal paperclip, more dense than water, can float on the surface of water, or why certain insects can walk on water. Surface tension is strong enough to hold them. Surface tension is also why water beads up on a surface. It's all those H2O molecules huddling together, which is the opposite of what you need H2O to do when you're using it to clean. You need it to spread quickly over a dirty surface, on your skin or hair, your clothes or your dishes, to start to loosen the dirt. And here's where soaps and detergents come in. By the way, there is a difference between the two. Soaps are produced from natural products like animal fats and oils and lye. Detergents are synthetic, man-made. But since both chemically work the same way, we'll use the terms interchangeably here. So, what you need to do is break the tension, the surface tension. Soaps and detergents can do that because they're surfactants. That's short for surface active agents. Surfactants act to reduce the surface tension of the water, break apart those H2O clicks. Soap and detergent manufacturers sometimes refer to this as making water wetter. We'll give you a second to process that. Okay, moving on. This wetter water is more effective at breaking up dirt, especially oily dirt.
In reducing the surface tension, you basically separate the water and you allow it to incorporate the oil better. It doesn't hold on to itself as strongly.
To get a better idea of just how soaps and detergents work, let's take on the case of the greasy frying pan. Wash it out with water alone and it stays greasy. Those clickish H2O molecules stay together and ride right over the oily surface. Of course they do. Oil and water don't mix, right?
The idea that water and oil don't mix is a common misconception. It's not that they necessarily repel one another, it's that water would rather be with water than with oil.
Getting the water to mingle with the oil is exactly what a soap or detergent does.
It basically acts as a mediator between that oil-water interface.
It's a neat bit of chemical diplomacy, and here's how it works. Soaps and detergents are formed by molecules that look like this. One end that likes water, the term for that is hydrophilic, and a long chain or tail that doesn't like water. The term for that is hydrophobic. When soap is added to water, those water-disliking tails of the soap connect to, surround, a grease particle, forming what are called micelles, which look a little like dandelion puffballs. A cross-section of that puffball would look like a wagon wheel. Think of the grease or oil particle as in the center. These are the soap molecules surrounding the oil, connected to the water-phobic oil with their own water-phobic ends. Now look at the outer rim of the wagon wheel, the other ends of the soap molecules. They're water-loving, remember? So they connect just fine with all the H2O molecules.
You want the detergent to basically pull the oil and the dirt off your clothes.
Or your skin, or your hair, which is exactly what soaps and detergents do. They isolate grease or oil particles and suspend them in H2O long enough so they can be wiped off or rinsed away. Now, we haven't even touched on acid-base reactions here, how most soaps and detergents are bases and most grease and fats are acids, think fatty acids. So this isn't a full explanation of the chemistry of surfactants. Just thought we'd come clean about that.